All right, welcome to Chapter 4, Section 5, Compare Properties of Functions. This is for Math 8. So on the first screen here, the first thing you should see is your due date. I don't see that on the teacher preview, but you'll see it on your student screen. The second thing is the attempts. We always give unlimited attempts. You can come in and submit this assignment as many times as you would like. This particular assignment has 4 questions on it. And then grading policy is best score. Whichever attempt is the best one is one you keep. Partial credit is enabled, meaning if you answer 1 of 4 questions, you keep credit for the 1 question. This statement down here just says, please remember once you start your homework, you must finish it before you can work on anything else. So that means once we click start, down here in the bottom right corner, we are going to need to click the submit assignment button whenever we're ready to leave this screen. So as soon as we're done or we've worked on something, we're just moving on, or if we haven't worked on anything at all, it doesn't matter. Once we click that start button, we click submit assignment. It does 2 things. It stops the system from locking you out, like that statement just said, because it will lock you out of all of your other assignments. And it also affects the grade book once you click the submit assignment. Before you click that button, it's just kind of frozen there. It doesn't do anything. So get in a good habit, click that button. Over here we have explanation, example, and message center. So explanation tells me I'm going to lose my current question attempt because it's going to give me the answer to this question. It's not going to give me the answer and then let me come type it in, right? That doesn't work. Example gives me an example of what I'm looking at here. So it's going to show me a very similar problem, and then it's going to let me work through it, showing me how to work through it, and then how to answer the question down below. Message center is just so that you can literally message your teacher with a picture attached so that your teacher knows where to come help you. Let me see. I'm going to do this really quick so I can snap a picture of this and put it on my whiteboard there because it's a little easier, I think, to write on this than. So minimize again. Scoot you over. There we are. Okay. So, and I'll do that for both of these guys because it's a little easier, I think, to actually look at the pictures and stuff and be able to draw on it. And for some reason, I can't draw on this screen from Alex. I don't know why. I can draw on pretty much all my other screens when I'm using the markup tool on Google, but this screen doesn't work. All right. So 3 pumps are pumping fluid at a constant rate for each. The amount of fluid pumped depends on time as shown below. So we're just getting 3 representations of this situation. And they're different situations, but they're all pumping fluid at a constant rate. So we have a graph, we have a table, and we have an equation. So the first 2 here are very visual. This one is definitely more visual than even the table because I get to see this relationship. It's a line. The table gives me all the data points. And then, of course, the equation is something that I can manipulate and work out and find more data points with. So what they're asking us to do for each one, it says, what is the rate of each pump? So it's liters per hour. So liters, this would be, and I'm going to kind of relate this would be rise over run. They're kind of asking us what's the slope in this case. They want to know what's the change in L over the change in H. So with this one, we just want to take a look, and a really easy one to do is to go to 1. If we go to 1 for run, so 1 on the bottom, and we just go straight up and go, okay, well, here's the point, and that would be, for this guy, this would be 80. So that makes it a little easier if we just find the 1, because it's divided by 1, which just means it goes down to just 80. So we can go over here and just type in 80. For pump B, same thing. I want to find where it's 1. So I'm going to go here, time hours, 1. So my fluid would be 90 minutes. So this one pumps at 90 minutes per hour. Okay, or 90 liters per hour. So the first pump was 80 liters per hour. The second one is 90 liters per hour. So this last one I want to do the same thing, but I don't have something to visually look at. So what I need to do is just plug it in and go 1 times 70. Well, 1 times 70 is 70. So this one is 70 liters per hour. So I can go over here and go 90 and 70. And then they say which pump is the slowest. So we just want to know which one is, pumping the least amount per hour. So 70 is smaller than 80 or 90, so it's going to be pump C. And then they're asking us to look at how much fluid will they have pumped in 3 hours. So kind of taking the information we just learned and going a little farther with it. So if I can use the table and the chart, the graph and the table to find this pretty quickly. I can go, well, at 3 hours, there it is. It's going to be 240 for this first one, for pump A, 240 liters. For pump B, I can go to the table and go, well, at 3 hours, how much have I pumped? 270. For pump C, I'm going to have to plug it in. So it's going to be 70 times 3. So 7 times 3 is 21, and then I put the 0 back on. So it's 210. So this is another way of seeing, yeah, pump C is definitely smaller. It's pumping the slowest. All right, let's see. Perfect. Let's just go through. And I think in class someone had mentioned that you had to have the 1 underneath. I think it will accept the 1 underneath, but I don't think it has to be there. All right, so we're going to do the same thing. Now we have airplanes traveling at a constant speed, so it's the exact same idea here, but we're going to go through and do meters per second. So meters per second. So we're going to do the exact same thing we just did on the last one. We want to find the slope, what is the speed of each airplane, we want to do 1 second, and I want to know how many meters they've moved after 1 second. So if I come here to this graph, I have 1 second, and it would be 500. For airplane B, I'm going to need to work this out, so I'm actually going to go ahead and work it out right on here. So 480 times 1, well, that's just 480, right? So this one's going to go 480 in 1 second, 480 meters. And then this last one, airplane C, after 1 second, it's gone 460. And I know I'm not writing on the screen like I was before, but I'm doing it with the mouse. You can kind of follow along with that one. So now, which airplane is the fastest? So we're not looking for the smallest number, we're looking for the largest number. So it's going to be airplane A, because the 500 is bigger than 480, which is bigger than 460. So now they want to know in 2 seconds how far have the planes traveled. So we can go back to the graph here and go 2 seconds and go, well, it's traveled 1,000. Can I also use multiplication here? If I know that it goes 500 meters per second, well, 500 times 2 is 1,000. I can definitely use multiplication here too. I don't have to use the chart. So with this one, I'm going to do 480 times 2. So let's see, we get, I believe that's 96, if I'm doing that correctly in my head. Yep. So 48 times 2 is 96, and then I can add the 0 back on. So 960 for airplane B, and then I can go here, 2 seconds, 920. Check. All right, so now we're going to do these next two. And what we're going to do on these guys, so let me snap a picture. And I know I had these written a little bit differently in class when I was doing them, because I actually kind of separated out the questions so we could answer the different tasks here. So now we're given 4 functions in 4 different ways. So we're given a graph, we're given a table, we're given an equation, and then we're just kind of flat out given some information here. So we're going to do some comparing. So each function has the graph, which function has the graph with the greatest y-intercept? Well, if I want to know which one's the greatest, I need to identify the y-intercepts of each one. So we're going to go through here, we're going to identify. For function number 1, I'm on the y-axis, my y-intercept is right there, that's where it's crossing. So this would be -1. So I'm going to write -1 here, just so I have it noted. For function 2, we're looking at a table. If we think about the y-axis, I'm not going right or left, I'm right on top of the line, which means that I want x to be 0. So there's my y-axis right there, and I'll keep that guy circled so that we can kind of see this. So my y-intercept is 5 for function number 2. For function number 3, we're looking at the graph here, and remember we have y equals mx plus b, and we've been using this one for a little bit now. So if we remember, the slope is the m, b is the y-intercept, so I can identify that very quickly as -4. And then they just told me here that the y-intercept is 2 for function number 4. So which one is the greatest? Well, that would be function number 2, because 5 is the biggest number out of all of these. So now, if we go down and we say which functions have graphs with slopes less than -2, well, I need to know all their slopes. So with this one, I'm going to say, well, how do I get from here to here? So I go down 1, 2, 3, and I go over 1. So rise over run means that this is going to be -3. So this is -3. And for this one, what I need to do is I need to look at the change for each one. What am I changing by? So in this one, I'm going up. I'm adding 1 each time. That's my run. And then I'm changing this one each time. So this is my rise. So I'm rising by 4 each time here. So if I add 4, I go from -3 to 1. If I add 4, I go to 5. If I add 4 again, I go to 9. So rise over run, and I can just reduce that to 4. All right, so this one, I can just identify it with my equation here. M is my slope, so it's 2. And then they told me in function number 4 that it's -1. All right. So now, which ones are less than -2? Well, the only number here that's less than -2 is function number 1, it's -3. And then which function's graph is the least steep? So since they're all integers, meaning that the run is 1 for each one, what we want to do here is if it's the least steep, then I'm looking for the one that's either going up or down the slowest. So I'm looking for the number that's closest to 0. And function number 4 has a number that's definitely closest to 0 there. So this would be function number 4. All right, so let's go ahead and click these. Boom, and then it was function number 2. Check. All right, and we're going to do one more of these. I think it's identical to that one, just different numbers here. So we're just going to go through and kind of test these out. If I remember in class, the numbers even ended up being very, very similar to each other. Okay. Yeah, okay. Yep, all right. So let's go ahead and do this. So now I have -2 and I'm starting at -2, I'm going up here, and I would go up to this point. So I kind of jumped in. Sorry, I should probably slow down and read the question because I kind of already glanced at it real quick. So we have the same representation here, a graph, a table, an equation, and just kind of flat out information given to us. So which function has the graph with the y-intercept farthest from 0? So this is not saying which one is the greatest. Which one is the farthest from 0? So that could be negative or it could be positive. It's just the distance from 0, which one's the farthest. So we need to know our y-intercepts again. So I'll go back to red here. So here's my y-intercept for this first one. I just go, where is it crossing the y-line? And it's -2. I look for my 0 in the table. So it's 3 for this one. For this guy, I'll write out the equation, mx plus b. So there's my y-intercept, because it's the b term. It's the term that's being added or subtracted. And then function number 4, we have a y-intercept of 1. So which one is the farthest from 0? That would be -5, because it's not the greatest. 3 is the greatest, but 5 is farther from 0 than 3, because it's -5 units to the left, or down, actually. So it would be function 3. Which functions have graphs with y-intercepts greater than -3? So we already did the y-intercepts. We don't have to identify them again. So I can just go in here and say which ones are greater than -3. Well, all of them except for function number 3. Number 3 is less than. But each one of these are greater than -3. 1 is greater than -3, 3 is greater than -3, and -2 is greater than -3. And then which function's graph is the steepest? So this one's actually pretty different compared to the ones we did in class, because we didn't answer this question. A lot of the time they've been doing this one based on slope. So if I want to know which one's the steepest, I need to know the slopes. So for this one, I'm going up. Darn it, that was a horrible line. Up and over. So let's see, I'm going to go up 1, 2, 3, 4, 5. and over 1. So this is a slope of 5. So that means every time I move over 1, I go up 5 units. And we're looking for the steepest, so we want something to go the fastest, either up or down. We're not looking for negative or positive. We're looking for basically which one's run is the highest. So for this one, I can see I'm going up by 1 each time. I'm adding 1 here. And on this one, I'm going down, so it looks like I'm subtracting 4 each time. So it's minus 4. So this is a slope of just negative 4. So far, function 1 is still winning. 5 is more than 4. And I'm not talking about negative or positive. I'm just looking at the number itself. This would go up 5 units every time I move over 1. This would go down 4 units every time I move over 1. So this is faster so far, even though it's going up instead of down. All right, function number 3. This guy is a negative 2. And this slope is a 3. So far, function number 1 still wins. All right, so we have function 3, 1, 2, and 4, and then function number 1. Check. All right, so that was section 5, and I will see you, I don't remember if this is the last section in chapter 4. That I can kind of look really quick. Nope, not the last section. So I will see you in section 6.